Hi class, this is section 6.1, so we're starting a new chapter and it is going to be the study of circles. So we're going to be doing a lot of constructions in Sketchpad. So this is our first investigation. As you can see from the picture, we have a circle O and then tangent T. So if you remember from your definitions from chapter 1, a tangent to a circle is a line that touches a circle at only one point. So the first thing we are going to do is draw or make a circle in Sketchpad and then make a tangent. So let's open up Sketchpad. And we will start with a circle. Now, we have not done too many of the constructions, the circle constructions, other than just make a circle. So let's take a look at those. If you look down here, it says circle by center and point, circle by center and radius, arc, and arc through 3 points. So these are things that we will be looking at as we do this study of circles. So right now we just want to make a tangent line through this point. So we're going to highlight that point, and then we're going to highlight the circle. And you notice it doesn't say construct a line, doesn't even let me do the line. So what we need to do is highlight this, the center point, not highlight the circle, and we need to construct a segment. And now we need to just highlight this point and the segment and construct a perpendicular line. And that makes the tangent. Okay, so no matter how I move it around, that line will stay tangent. Now we constructed it perpendicularly, so you know that that angle right there is a 90-degree angle. And I'd rather it make the 90-degree marks. Let me see if it'll, I guess it's not going to do it for me. There we go. So now we have the markings. So let's take a picture. And we can put this in our notes to go along with the conjecture. So let's go back to conjecture 53. So this will be the first one of chapter 6, titled Circles. It says a tangent to a circle blank, the radius drawn to the point of tangency. So we need to fill this in with the word perpendicular. So a tangent to the circle, perpendicular to the radius, drawn to the point of tangency. Okay, so let's move to the next one, tangent segments. So you can see the picture here in this investigation. So we have two tangents. So now we're going to add on to our picture and look at what the conjecture reads. Tangent segments to a circle from a point outside the circle are blank. So let's see if we can figure out what we're going to fill in there. So let's go back into Sketchpad. I'm just going to put another point on my circle. and then I need to make a segment so that I can make that tangent line. Okay, so now I have the second tangent. Notice the two lines intersect down here. So let's define that as a point. And now I am going to construct these two tangent segments. So notice the 2 points that I have highlighted. Now I'm going to say construct segment. Then I'm going to come over here and construct a segment. Now, as you know, we're just coming off our study of our polygons. And we know radii are the same length, so these two radii have the same length. Do you think we have constructed a kite? Would be the question. So let's see. Let's measure these two lengths here. And yes, they are the same length. I'm going to hide this point. So we have constructed a kite. So by making a circle with two tangent segments, we've made a kite. So remember what we know about a kite, that the non-vertex angles, which in this case are angle A and angle C, are congruent, and we know that they are congruent because they're both 90 degrees. That's how we constructed them. And then the vertex angles going this way, in this case, they are going to be supplementary of one another. Okay, so let's take a picture of this and see if we can complete our conjecture. So put that in your notes. Let's look at what the conjecture says. Uh-oh, wrong direction there. Tangent segments conjecture, conjecture 54. Tangent segments to a circle from a point outside the circle are, how are we going to fill that in? Yes, they are congruent. So tangent segments from a point outside the circle are congruent, but they must be tangent for that to be true. Okay, we're going to talk a little bit more about arcs and angles, which we talked about in chapter 1. I'm not so sure if you remember it or not. So let's look at this picture here. In the figure at the right, the central angle, angle BOA. So remember the definition of a central angle, the vertex of the angle is on the center of the circle. It determines minor arc, arc AB. So the angle makes the arc, and then look at the measures. The central angle is 40 degrees, and the intercepted arc is 40 degrees. Okay, so let's go into Sketchpad and do our own picture that will show us the same thing. So I'm going to construct a circle. I'm going to put another point on the circle, and then I am going to make segments to form an angle. I'm going to measure this angle. And then I'm going to measure the arc. So I'm going to highlight point A and C, and then highlight the circle in order to measure the arc angle. Okay, arc angle. The length would be the actual length from point A to point C, and we will talk about that later. So you can see the intercepted arc, AC, is equal to the measure of the central angle. And that is something that we learned in chapter 1. I just wanted you to remember it. So I'm going to take a picture, and you might want to make a note there that the central angle will equal the measure of its intercepted arc. Okay. Another thing you will want to remember are the measures of your arcs. Again, you might want to review notes from chapter 1. When it is less than a semicircle, notice what happened to my measure there. Then it started measuring it this way. So when there's only 2 letters in our angle, then it is assuming that it is a minor arc, so less than a semicircle. As soon as I put another point on my circle, then I can talk about the measure of the major arc, which is bigger than half the circle. So I'm going to highlight A, this little point here, and point C, and then highlight the circle and say measure arc angle. So notice the 3 letters, and it's 230 degrees. These 2 added together will make 360 degrees. So arc ADC is a major arc. Arc AC, named with 2 letters, is a minor arc. So you will want to review those definitions from chapter 1. And then one other thing I'd like to talk about are tangent circles. So circles that are tangent to one another, and whether they are internally tangent or externally tangent. So I'm actually going to start with a new picture, and I'm going to make a circle, and from that circle I'm going to go, not there, start here and come, oh, that was the same circle. Let's see, if I want to make it, let's see, I'm going to highlight this point, and I want to make it externally tangent. So I'm going to put another point, well, I can go to the circle, and I'm going to start here, and I'm going to have it connect at that point. But I only wanted to touch at that one point, and you can see that these circles are intersecting at 2 points. So that is not going to be tangent circles. We want to construct them so that they only touch at 1 point, on the inside and on the outside. So if I highlight these 2 points, and I construct a segment, then I am going to find the midpoint of that segment. Now I'm going to go back to my circle button and go here and hit that point. Those are internally tangent circles. Okay, internally tangent. Now to make them externally tangent, and I can keep making internal tangent circles. So I could find the midpoint of this segment, and then do it again. So those are another pair of internally tangent circles. They only touch at the one interior point. In order to make them externally tangent, I need a perpendicular line here. Once I get the perpendicular line, then I can make externally tangent circles. So I'm going to highlight my line segment there and highlight this point, and I'm going to say construct a perpendicular, but then I also want to extend this segment. So I'm going to hit this here and go construct. I want to construct a line, so I guess I only need 2 points highlighted. Okay, so we see the diameter. Now if I pick any point on this circle, or I'm sorry, on the line, I will be able to make an externally tangent circle. So I've got the point highlighted, and you can see those are externally tangent. Now I've made internally tangent and externally tangent lines. Okay, so these are, that one is externally tangent. Okay, so internally tangent, the two circles, one's lying on the interior of the other one. Externally tangent, the circle's lying on the exterior of the other one. So I will take a picture, and you can put it in your notes. And talk about internally tangent and externally tangent. Okay, this concludes section 6.1. Study your definitions, and I will see you in class. Here is another picture of internally and externally tangent circles, and we will look at these examples in class.